Hi, I'm Andy, and this is my lesson on class hierarchies in Java. In this lesson, I'll show you how to add several new subclasses to a project, and how to draw diagrams that show how those classes are related to each other. Let's get started. Let's add a few more classes to the online store project we've been working on the past few lessons. Right now we have two classes, store item and book. Because a book is a special kind of store item, with a few attributes that differ from normal store items, we made it a subclass of the store item class. Now suppose we want to sell audiobooks as well as regular books in our online store. An audiobook is a book, but it's a special type of book. Therefore, we'll make an audiobook class that is a subclass of the book class. Because we made audiobook a subclass of book, and book is a subclass of store item, the audiobook class has all the variables and methods defined in both of those classes. Which is exactly what we want, because an audiobook is a book, so it's also a store item. The audiobook class will have just one additional instance variable, a string called file name. So now audiobook objects have 7 instance variables, 5 from the store item class, 1 from book, and file name. Now we need to make the constructor to initialize those instance variables. The first line of a subclass's constructor should always be a call to its superclass's constructor. So let's add that in here. This call to super will call the books constructor, which then calls the store items constructor. This ensures all the inherited instance variables get properly initialized. Then we need to initialize the file name instance variable. Now for the methods. Audiobook inherits all the methods defined in book and store item, so it already has a bunch. We just need to add one additional one, a getFileNameAccessor method. Then we need to override the getCost method from the book class. Audiobooks have no shipping costs because they're simply downloaded as a digital file. Also, it doesn't make sense to buy multiple copies of a digital file, so we'll ignore the quantity parameter and just set its cost to be its price. We also need to override the toString method, so that the information returned here includes the file name. Now let's make one more class, this one called grocery store item. A grocery store item is slightly different than a regular store item, because it may be a refrigerated item, and if so, it's going to have a higher shipping cost. Now a grocery store item is definitely not a special type of book or audiobook, so it won't extend those classes. Instead, it's a special type of store item, and will therefore inherit from that class. Let's represent the additional shipping cost by using a constant called refrigeration surcharge. This class has just one additional instance variable called refrigerated, which is a Boolean value that tells us whether or not the item is refrigerated. Now we'll make the constructor just like we did for the other subclasses. and we'll make an accessor method for the refrigerated variable. Now let's override the getCost method. First, let's make a variable called cost, which will be the base cost for this item. Its base cost is calculated the same way as any other store item. We do that by calling the superclasses version of getCost. But if the grocery store item is refrigerated, the cost is a bit more. We need to add a surcharge to the item's cost. Now we end the method by returning the cost. Lastly, we need to override the toString method to include the value of the refrigerated variable. We do that just like we did in our other subclasses. So now our online store project has 4 classes: store item, book, audiobook, and grocery store item. These classes are all related to each other through the extends keyword. To visualize these relationships, what we call the class hierarchy for our project, we can draw an inheritance tree diagram. We first draw the root of the tree, the parent class to the other classes. In our case, that's store item. These diagrams can show as many details as you need. To keep things simple, we'll show just the names of the variables and methods, but not their other details. Then we draw the subclasses and connect them to their parent with an arrow. For example, here's how we add the book class to our diagram. Some people like to draw the arrows in these diagrams going the other way, from parent to the child, but drawing them from child to parent is more common. Now we can add the audiobook class and grocery store item class to our diagram. These diagrams are great because they convey a lot of useful information. For example, they show what methods are available to our classes and which method will execute when one is invoked. When you invoke a method on an object, the first version of that method encountered as you follow the arrows up the tree branch from that object's class is the one that ends up executing. For example, if you invoke a method on an audiobook object, Java will look for that method by starting in the audiobook class and then working its way up the inheritance chain. If the method is not encountered as you move from the object's class up the tree branch, you will get an error when you try to invoke it on that object. For example, let's see what happens when we invoke the getAuthor method on a grocery store item object and the getFileName method on a book object. Notice neither of these methods calls should work, since those methods aren't encountered as you move from the class up the inheritance tree. These cannot find symbol errors are telling us that the Java compiler couldn't find the invoked method as it searched up the inheritance tree, which is exactly what we expected to happen. And that wraps up this lesson on class hierarchies in Java. I'm Andy. Thanks for watching and coding with me today.